Okay, so we are starting the October 2023. Hopefully by today and our next class, we'll be able to finish this paper. So if we start with the first question, that is about moment, right? Figure 1 shows the beam AB with weight 24 and length 6. Okay, so the weight is 24 and the total length is 6 meter. The beam is suspended by two vertical ropes and the ropes are attached to the points C and D. On the beam, AC is X meters and CD is 2 meters. Okay, X and 2. The tension on the rope attached to beam at C is double is the tension in the rope attached to D. That means if your RD is X, then your upward reaction force from RC is going to be 2 times of that X, right? That's what the last statement says. The beam is modeled as a uniform rod. By the term uniform, we understand that that 24 Newton weight was actually acting exactly from the middle, right? 3 centimeters or 3 meters from each side. So this is your 24 Newton. And now find out the rope, tension in the rope at D and also the value for X, the distance between A and C. First thing, if they're asking for that value for that X, that can be easily calculated. I don't have any other forces acting on this beam other than that two tensions and the 24 Newton, right? So in the upward direction, you have this 3x total, and in the downward direction, you have this 24. If the entire thing is in equilibrium, right? Equilibrium word, I know, from that word, I can understand the total resultant force is exactly 0 Newton. So resultant force means what? All upward, then plus downward or minus downward because of the difference in direction. That will be equals to 0. All the upward forces cancel out the downward forces. So for part 1, you can easily calculate this as resultant force 0. Upward you have x plus x minus downward you have 24 and that is equals to 0. So you have this 3x 24 and eventually you'll get this as 24 over 3, which is 8, right? So you get the value for your x as 8 Newton. Sorry. Oh, we cannot use x because x was already used. Let's use a different alphabet for it, okay? Because x was already used for the distance. So just think of this as any random alphabet. Y, y. But otherwise, the calculation was correct. Problem is, this y gives you, oh no, this is it, right? Yeah, the wait, one tension in the rope attached to C is double the tension in the rope attached to beam D. Yeah, sorry, that's correct. I mean, in D, whatever you had, twice of that will be the tension at rope C. So, I mean, we can consider the tension in rope D is just Y, which is 8 Newton, right? That's it for part A. For part A, I didn't use any moment basics. I only used the overall resultant forces concept to find out that. For part B, now they were asking to find out the value for x. I can easily calculate that. I'll try to take the moment about point x, sorry, about point A. Then I just have to think about that what is this moment was making a distance with the end, with the pivot over here. I understand that this is going to be upward. Like if you eliminate all the forces, this 2y force will actually make the beam move in the anticlockwise direction. This would also make the beam move anticlockwise direction. Only this 24 Newton will make the beam move in the clockwise direction, right? So in that sense, we can understand that your total moment anticlockwise is equals to total moment clockwise, right? So for your anti-clockwise, what do you have? Upward, you have this 2i, which is now I know 8. So this is going to be like 16, and this is 8, right? So that 8 multiplied with x. So you have 8x, and that, sorry, this was actually 16 because this was for C, and for D it was 8. For D was actually 2 plus x meters away from A, right? So we can write 2 plus x, and again weight was 24, exactly at the middle. That means obviously halfway from the end A, halfway of 6 is going to be 3. So after this we can write, okay, this is 16x, then 16, then again 8x, and 24 into 3 is 72. So you get, I can just add all the x's together. 16 plus 8 is going to be 24x, and then again 72 minus 16, that is 56. So if you get the value for your x, that's going to be 56 over 24, right? 56 over 24, that's 7 by 3, which is in decimals. It's actually a continuous value in decimal, 2.6, 3333. It's better we can write this in mixed fraction maybe, which is going to be 213 meter, right? So this is your final length for that x meters from A to C. Any problem from this part?
No, teacher.
No.
Okay, so we're done with the question 1 again. After this, we'll move on to question 2. This is an acceleration time graph. It says that 2 points A and B on a straight horizontal line, and the acceleration time graph in figure 2 represents the motion of a car traveling along the road as it moves from that AB. At time t0, the car passes through A at a velocity of 8. This is the initial velocity. After 20 seconds, the car passes through B at a velocity of V. Find that, show that that velocity was V. I can understand that everywhere the car was not accelerating at the same rate, right? For the first 4 seconds, the car was accelerating or decelerating at 0.5. Started at 8, right? Maybe if I just draw the diagram, started at 8 meters per second. After 4 seconds, they decelerated with a value of A as negative 0.5, right? After this, from 6 to 10, zero acceleration means what? Over here, they never said that the car was not in motion, right? After the deceleration, you have to understand what was the velocity that you get finally after the deceleration. That would decide that if the car was actually in rest over here or in constant velocity. So if you are decelerating at like 0.5, 4 minus 1 minute. Yeah, 8 minus 4 into 0.5, 0.5. That's actually 6 seconds. Okay. So for the first 4 seconds, it started with 8. Its velocity decreased to 6. By 2 unit, it decreased. And after that, it starts to continue with the constant velocity. That's why we cannot see that acceleration was 0 here. We have a horizontal line on the x-axis. Now, acceleration 0 can also mean the object was was at rest at this time. But I know that after the first portion, the object's velocity was 6. From 6 to within a second, it cannot go to a rest position, right? So from 6 to 10, it was moving with constant velocity of that 6 meters per second. That's what we understand from this diagram. So this 6 meters per second was maintained for the next 6 seconds. After that, from last 10 seconds, in last 10 seconds, object was accelerating at 1.2. So you have this 10 seconds and acceleration is 1.2. Now use a calculator. 6 plus 10 into 1.2, that gives you exactly 8 meters per second. So this is how you have to get to this idea or answer over here. First, you have to find out the answer for the first decelerating section, then constant velocity, then use that, because the final velocity of the decelerating section was actually the initial velocity for your acceleration, right? So I just have to draw all these things. Write all these things as a part of my calculation. So this is important thing. So we'll just write it over here and work our calculation here. I'm going to find out that for the decelerating part, I want to find out the final velocity, which is u plus 80. U was 8 plus a is 0.5 minus, and then time was 4, right? So eventually you get your answer as 6 meters per second. For the next 6 seconds. After this, then again continue with your accelerating part. For the accelerating part, you have your v equals to u plus 80. That is again v. So far, your v is now 6, right? So 6 plus 1.2 into 10, and that's going to be 18 meters per second. So this is what we had to show in part A by calculation. Any problem from part A calculation?
No teacher.
Now, whatever I have calculated in part A, all the informations, I have to represent that on a velocity time graph. So for that velocity time graph or speed time graph actually, when over here velocity will not be much more different because everyone was traveling in a same direction, okay? So if you are starting from 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, let's consider each line over here for 2. From 8, it decreased to 6 within the first 4 seconds. Then from 6, it continued to 6 for the next 6 seconds. After that, it started from 6 and continued to 18. Fayad, if you don't have any question, please keep your mic off, okay? Time in seconds and velocity in meters per second, right? This is how your graph should look like roughly. That's it. This is your everything you have to show. Then after this, I mean, in this calculation, we already did all the calculations, right? Your deceleration was at negative 0.5, acceleration was at 1.5. So obviously this portion has to be steeper than this portion, right? That thing you have to keep in mind, that your acceleration was at a greater rate compared to your deceleration. So obviously acceleration has to be very steeper compared to your deceleration. Then again, after this, now they're asking that, okay, calculate the distance between that A, B station. So if this is A, this is B, I can understand that now they are creating this one as a trapezium, right? This one as a rectangle. Is it rectangle? Yeah. So it's a square mostly, right? 6 and 6, it's a square now. And then again, this portion is your another trapezium. So I just have to find out the area under the graph, which is 2 trapezium and 1 square. So area over here is going to be first one, 8 and 6 are parallel sides, 4 is the height. So half 8 plus 6 with 4, adding this with 6 and 6, then again adding this with 6, 18, 10. So half 18, 6, 10. And then just calculate all these over here. We have 4 by 2, then 8 plus 6 plus 36 plus 5 into 18 plus 6. You get 184 meter. And that is your option, answer for your option C. Any problem from this part? Only part A was a little tricky. B and C was quite regular, right? Any question from this question 2?
No teacher.
Okay, then if there is no problem, we are done with question 2 also. We will move on to question 3 quickly. It says that a hammer is used to hit a tent peg on soft ground, and the hammer has a mass of 1.8 and the tent peg has a mass of 0.2 kg. The hammer and tent peg are both modeled as particle and the impact is modeled as a direct collision. When over here what happens? The peg was obviously horizontally resting on the ground in certain position and you move the hammer to hit the peg. Right? Eventually the peg and hammer after that collision will move together for small distance to make that peg enter the surface of the ground, right? That is the main motive what we're doing here. And initially it says that immediately before the impact, the tent peg is stationary. Obviously, it was supposed to be stationary and only the hammer was moving downward with velocity 10. And immediately after the impact, the hammer and the peg move together, they connect together and they both move vertically downward with the same speed of v. And we're supposed to calculate that. So this is obviously an important, basic. If I want to draw this as your collision diagram, this is how we will draw. This is your hammer and peg. This was moving towards the hammer, so towards the peg at 10 meters per second. This initial velocity was 0 meters per second. Both of them moved in the vertically downward direction with a velocity of v meters per second, right? Everywhere in this diagram, everyone is moving in the same direction, so we don't need to assign that left is positive, right is negative, nothing like that. Part A, we have total momentum before collision is equals to total momentum after collision. Before collision, we have 1.8 into 10 plus 0. And then again 1.8 plus 0.2, that is the total mass combination of hammer and peg multiplied with V. So you have 18 and this is going to be 2V. So you can clearly understand V is going to be 9 meters per second. After the collision, they were both moving in the same direction, vertically downward at 9 meters per second. Is this clear? Any problem from part A?
No, teacher.
Then if we move on to your next one, for the next one, they're saying that find the magnitude of the impulse exerted on the tent peg by the hammer, stating the unit of your answer. Magnitude of the impulse is going to be like what? Change in velocity of the peg, right? Like initially the peg was not moving at all, and after the collision, the peg started to move with a velocity of 9 meters per second, right? Multiplied with the mass, obviously. So that will give you the value for your change in momentum. So for part B, so impulse on peg means that you are supposed to use the information of peg for this calculation. General formula is mv minus mu. M is 0.2, v is 9, u was 0. So that makes the entire mu negative, mu 0. So I'm just going to write it like this. And after this, you get your answer as 1.8, right? Yeah, 1.8 kg meters per second, right? Another thing, in this situation, most of the every like over here, even though the diagram looks like everyone was traveling in the vertical, so horizontally to the right, but actually in real life, when you were hitting the peg with the hammer, I really wanted the hammer to get into the ground, right? That means everything was moving in the vertical plane, and everyone was also moving in the vertical downward direction. So if everyone was moving in the vertical plane and everyone was moving in the downward direction, this is how during the impact the forces were acting on peg and hammer. On peg, it was acting in the downward direction, and on hammer, obviously according to Newton's third law, peg after receiving the force will not just stay there silently. Peg will also reply and exert the equal amount of force in opposite direction on the hammer. So this is on hammer. So when you are trying to find out the change in momentum on peg because of the collision, obviously we'll focus on the change in velocities of the peg, and this time everyone was actually moving in the downward direction. So without mentioning, I said that I actually assumed over here that downward is positive. Okay, if downward is positive in this case, in that sense, what we can see, if downward is positive, then everyone, this hammer and peg, they're moving in the same direction. But if you think about their impulse, only peg will have a positive impulse because on peg the force was acting in the downward direction. But on the hammer, it will have a negative impulse because impulse is related to force. If someone has negative force, depending on the direction again, so obviously that impulse will also be negative. So on hammer, peg exerting an upward force, so that's why the hammer will have a negative impulse and the peg will have a positive impulse. So according to your maths calculation, I was looking for the impulse of your peg. So peg will have a positive 1.8 kg meters per second. Even though they never said that, okay, find out the direction also, but we can understand that it's going to be positive according to our calculation and assumptions. Is this clear?
Yes, teacher.
Fayad, any problem from your side? Okay, this is it. Plus and minus impact, depending on whatever you're working with. Okay, then again, after this, now they're saying the ground exerts a constant vertical resistive force of R newtons, bringing the hammer and tent peg to rest after they travel a 12 centimeter. Find the value of R. This time, what happens? For part C, you're not supposed to calculate them or consider them separately. Okay, this is how that space they have created inside the ground, and exactly over here, how far they have traveled. 12 centimeters they have traveled into the ground, and this time when they're traveling, they were traveling with it as a combined mass, right, which was 1.2 and that 0.2 meter. So you have the combined mass of hammer and peg, which is 2 kg. And what else? 1 minute. And there was this resistive force acting. You have to understand that if you just draw hammer and peg like this, obviously in the downward direction you have their both of their weight acting, which is 2g, and against them you have this resistive force acting, right? We have to calculate that resistive force, and I know that with the reference to that resistive force, they could only travel 0.12 meter. So I just have to find out the value for your r, right? If I want to find out the value for R, I have to use my equations of motion here. One thing to understand, that exactly after the collision, exactly the time when particle hammer was hitting particle tent peg, they combined together and they started the velocity with v, right? V equals to 9. That's what we calculated in the previous part. Using this 9, this could be their initial velocity here, and using this 9, because of the air resistance, or sorry, because of the resistive force, they eventually come to the rest at the bottom of this 12 centimeter, which is going to be 0 meters per second. So from this side again, I can understand that okay, initial velocity was 9 for the entire system, and final velocity was 0 because they eventually came to rest after entering 12 centimeters into the ground. So if I can find out s here, sorry, acceleration here, it's going to be v square minus u square divided by 2s. V square is how much? V square is 0, right? It eventually came to rest at the end of the tunnel. And then this is going to be 9 square divided by A is obviously, S over here. Object is obviously decelerating. So, and again, this was again a downward motion, so I cannot consider the displacement to be negative. Over here, everything is in the same direction, so everything must be positive. So you get your 0 point, is it 0.12? Yeah, 0.12 meters into the ground, right? So you have eventually 81, that is 337.5. Wait 1 minute. We get the value for your acceleration as 377.5 using this. And okay, we get the not exactly acceleration, right? We got the deceleration as 375.5. 337 of 75, 337.55 meters per second square. Why is it at deceleration? Because obviously you started with 9, ended at 0, velocity was decreasing. Only in one case velocity decreases, that is deceleration. Now using this deceleration, you can find out the resultant force, which is, by the way, weight minus R equals to that 2A. So this is going to be 2G plus 2 minus 337.5. It's actually going to be a minus. Eventually, they will add up together. So you end up getting 690. It's actually 94.5. So you can just write 695 Newton. That's all the working you need to do for part A. Any question from this part?
No, teacher.
Okay, then this is it for your resultant force. That's it for your part A also, right? We have completed. Part ABC, question 3 is done. Yes, okay. Then after this, if we move on to your question 4 quickly, in question 4, 1 minute. This is about vectors again, right? I think we did this in class, or maybe we didn't. Let's do this in class. In the question, ij vectors are horizontal unit vectors due to east and north, respectively. Particle P moves with constant acceleration, where lambda is a positive constant. When t is equals to 0, the velocity is this much. This is the initial velocity, right? Find out the velocity of P when t is equals to 5, giving you answer in ij notation, ij and lambda. I can understand that, okay, acceleration was what? Acceleration was negative I plus 2 lambda j meters per second. Initial velocity over here was 5I minus 8j meters per second, right? And now the time have been given 5 seconds. If I want to find out the final velocity, I have to use this one. This is going to be plus minus lambda multiplied with 5. So multiply them. You get 5I minus 8j, then again 5 lambda I, 10 lambda j, right? So just add everything together, like add I together. So you can write 5 minus 5 lambda. I cannot obviously further simplify it because of the lambda, but I can understand, okay, it's going to be 10 lambda minus 8j, right? And this is your final answer. This is the velocity you are supposed to calculate. Any question from this part?
No, teacher.
Like quite different because in all the worksheets we have seen so far, they don't have this acceleration concept, but they've introduced in here. Then again, they're seeing that the velocity was actually 13. 13 means what? The magnitude has been given. So for this kind of cases, whenever vector magnitude is given, you can write them as 5 minus 5 lambda, you basically I notation, then 10 lambda minus 8, j notation whole square root, and that is equals to 13. If you take the square root to the right hand side, you will have 25 minus 10 lambda plus 25 plus 100 lambda. Okay, made a mistake. This is 25 lambda square, sorry. Lambda square plus 100 lambda square minus 2 into 8 is like what? 16. 16 into 10 is going to be 160 lambda plus 64 equals to 13 square on the other side, right? So 13 square, it makes it 169. So now if you take all the x squared together, you have like 125 lambda square or x squared. Then minus 160 and minus 10 is your minus 70 lambda. And then again 25 plus 64 minus 169, that is minus 77. I think this is what we're supposed to show. Wait 1 minute. 25 and 8. Yeah, 25 and 8. 25 and 64. That's 89 minus 169. So this is supposed to be 80. Let's calculation it was 80 by 2. 80 by 5 is 16, right? Yeah. I have to take 5 as a common factor over here. It's going to be 125 over 5 is actually 25 lambda square. 70 over 5 is your 42. So 70 over 5, right? We are getting 42 in here. So let me see what is wrong over here. We had 5, 25 into 2 is, so this is going to be 50 and 160, right? Minus 50 minus 160. That's 210. It's supposed to be 210. Divide by 5 is going to make you 42. And 80 by 5 is going to make you 16, 0. Take that 5 to the right hand side, or obviously it vanishes from the equation. So you're left out with 25 lambda square, 42 lambda minus 16, 0. From this part, if I have to do middle term, obviously, to find out the value for your lambda, right? I mean, for first part B, I only had to show this. Second part C, now they're asking that find the direction of motion of P when t is equals to 4 seconds, giving your answer as a bearing to the nearest degree. Okay, again, I can understand that after 4 seconds, they're trying to calculate, right? So, and again, they're asking for the degree and direction of motion only, not about the magnitude or anything. So if they're asking me, this is it, lambda is just there. I don't need to work anything regarding lambda, or do I? I do. In order to find out the magnitude and direction, I do. They're only asking for direction, not even magnitude. So for part C, I can write that since the value for your t is now 4, I'm going to use the same expression, right? But problem is that now I will introduce the time value for t as 4 instead of 5. So we have the what I was looking for, the direction of motion p when you're giving your answer in this. Okay, first I have to find out the expression for v, which is going to be minus 5i minus 8j, or 5i minus 8j. Acceleration was just lambda I plus 2 lambda j multiplying with 4. So now you just have to multiply them. So 5i 8j 4 lambda I plus 8 lambda j, and then connect them together. For I, you have 5 plus 4 lambda I, and then again, plus this 8. 1 minute. Okay, so 8 lambda minus 8 j. Right, this is an expression for your velocity after 4 seconds. Now again, they were asking that I want to find out the mm, I want to find out the magnitude, right? Sorry, direction only. Problem is that with this expression, I cannot find out the direction. We have lambda there. So that means previously, from the previous equation, I had to calculate the value for your lambda. So we had 1 minute, 25, 42, and 16. And if I calculate from there, any questions, Asri?
I think it's minus lambda I.
Minus lambda I, okay. Oh yeah, minus lambda, yeah. It was negative then. So we wrote 8 lambda, and so this is going to be negative then, right? Minus 4 lambda, okay. So, I mean, if you solve this equation, okay, 25 lambda square 42 lambda minus 16 0, the value for your lambda, I'm skipping the factorization, but do not skip the factorization in your working. You either get 2 or you get minus 8 over 25, right? So these are the values, 2 or 8 over 25. So whenever you get this 2 and 8 over 25, I can simplify this further. But and again, I think somewhere it was stated that lambda is a positive constant. So if it's a positive constant, we will not accept 8 over 25 negative. So we get 2, 4 into 2 is 8, 5 minus 8 is actually minus 3. So you get is at minus 3i, and this is going to be 8. 3 minus 8, that's actually plus 16j. So remember that I was trying to find out the bearing, right? Sorry, 16. 1 minute. Minus I plus 2j, so it's going to be minus 4 plus 8j, and we had a minus 8. So 5 minus 4 and 8. Sorry, this is supposed to be 8J. Okay, now if I'm looking for a bearing, you have to understand that in which plane they are going to be created. Over here, this is what? Minus 3 plus 8, right? Minus 3 plus 8 means they are somewhere here, minus 3 and then plus 8. So if I want to find out the bearing, you have to understand that bearing was always calculated from the north plane all the way to this side, right? So I just have to calculate this portion by the way. The other three portion is already known, 90, 90, 90. So that's like 270, right? All these portion up to the negative x-axis, that is 270. I just have to calculate the shaded section, which is by 8 and 3. So that means this is your theta. Bearing over here is just going to be tan inverse opposite over adjacent plus 270 degree. Tan inverse 8 over 3 plus 270, which is going to be 339 degree. They never asked you for the magnitude, so we will not even calculate that. But even for the degree, I have to get rid of that lambda. So that's why from the previous part, I'll just shortly calculate the value of your lambda, use that in your final expression to get the velocity, and then find out the bearing of the velocity always from the north plane to that specific line. That's it for the vector calculation. Any problem from this question 4?
Not a teacher.
No, miss.
Okay, so we are done with question 4 also. I think today we can finish up to 5. Let's move to 5. Hmm. 5, it says that a small ring of mass zero point 0.2 kg is attached to one end of a light inextensible string, and the ring is threaded onto a fixed rough vertical. Fixed rough vertical means obviously there is friction, right? The string is taut and makes an angle of theta with the rod as shown in figure 3, and tan theta is this much. If tan theta is given, I'll always calculate sine theta, right? Because in most cases, I never want to calculate sine theta cos theta, but I have to because I want to work with the components. So this is 12, this is 5, this is going to be 13 in that case, just to make sure. 144 25 is 13. So you get your sine theta as opposite over adjacent, that's 12 over 13. Cos theta, 5 over 13, right? Adjacent over hypotenuse. Now they are saying that the ring is in equilibrium and the tension in the string is 10. The magnitude of the friction acting on the ring. I have to find out the magnitude of the friction. The tension will act in this direction, right? So if your theta is whatever it's given, this is t, it's going to be t sine theta and then t cos theta. In the downward direction, you have just this mg. These are the only forces that you can think of. And the ring was in equilibrium, so acceleration was not there. We need to find out the value for the friction, right? Another thing, if the rope was not there, the ring would slide down the rope, right? Or down that entire pole. Yes, down that light inextensible. Yes, 1 minute. The string is the friction will actually the ring will actually fall down the rod. So in that case, if it was going to fall down the rod, then in the upward direction you have friction also. And if you want to calculate that friction, I just have to work with mg minus t cos theta. But problem is, yeah, tension was also given. This was actually 10. So this is going to be 10 sine theta and 10 cos theta. So if I have to focus on the vertical plane, so for this kind of cases, always write resolving vertically. Object was in equilibrium in all planes, so resultant force 0. Upward, you have this friction and 10 cos theta. Cos theta is by the way 5 by 13. That is equals to your weight. Weight is 0 0.9, so 0 0.2, 9.8. And if I want to calculate friction only, so you just have 0 0.2, 9.8 minus 10, 5 by 13, right? So you just have to calculate this finally. 0 0.2, 9 point, that is minus 10, 13 into 5, 10, 5, 13. Wait, I'm getting Some negative answers. Yes, I'm getting negative answers from this part. Friction turns out to be minus 1.89 Newton. The reason is that the reason for the minus sign is that I assumed, right? To be honest, they never say that the ring will move down the plane. Because of the tension, the ring might be moving, is about to move up the plane, right? So in that case, if I assume the direction of your friction wrong, then obviously in that case, my calculation will give you a minus sign value. This minus sign represents that, okay, you assumed it in the upward direction, but in real life, the friction was actually moving in the downward direction, okay? So that's why your answer was wrong. So I can just write this. I don't need to like, cancel all my working and then again recalculate it. I can just write it that, okay, the negative friction indicates it was acting in the downward direction, right? So just writing this much is enough. You don't need to cancel all your working. That means the magnitude is still that 1.89 Newton in the downward direction. And I think in this case also they were only asking for the magnitude of the frictional force, right? So direction is eventually not even a matter. And state the direction of the frictional force acting on the ring. This becomes the direction, right? Since I know that according to my assumption, my calculation gave you wrong idea, that means obviously my assumption was wrong. And in my assumption, if I assume friction was acting in the upward direction in real life, it will be acting in the opposite direction, which is in the downward, right? Any problem from part A and B?
No, teacher.
No,
Okay, again, then they're saying that the coefficient of friction on the rod is 1 by 4, and the ring in its equilibrium tension in the string T newtons can vary. Find the maximum and minimum value. Okay, if I want to find the maximum and minimum value, you have to understand that this ring, okay, was in contact with that rod. That is totally fine, but in this case, it can be. I mean, over here it is contact with the rod, right? So, in this situation, it can be over here exactly perpendicular to the surface. Your surface was rod. So, reaction force could be here. Or if I want to identify that, how will you have your minimum force? It can also be in the vertical plane also, right? Like with this friction, right? With this friction and then cos theta. With that also, you can create the reaction force. So if I want to find out, like, in which direction I get the maximum minimum force, I will have to calculate that separately. So if I have to calculate the minimum force, for example, this one will be the minimum force because only R is equals to 10 sine theta is 12 by 30. So minimum force or minimum R, that's just going to be 10, 12 by 13, and then what else? 10 sine 13. Sorry, resultant force equals to 0 in the horizontal plane also. And then again, resultant force is going to be reaction force. Yeah, reaction force is equals to, so you take reaction force minus 10 sine theta equals to 0. So it's just going to be R sine theta. Sine theta is, by the way, 10, 12 by 13. So you get your answer as 120 by 13. That's actually 9 point, wait 1 minute. In the horizontal direction, we only have this, right? Yeah, we don't, it was only about to move up and down the slide. So friction will be in that case. 10 sine 30 is opposite by adjacent. They have also provided you 1 minute, what I was looking for. Oh, the minimum value for T they are asking, sorry. Now they are saying that the coefficient of friction is mu and Given that the ring is equilibrium, the tension in the string and the tension in the string T newtons can now vary. Okay, so using that idea, you have to calculate the value for your T. The value for your T is no longer 10 anymore, sorry. So in that case, I have to think about it then. I mean, obviously, if you're understanding that, yes, you have this reaction force on the left-hand side, and another thing that this tension, right, is actually pulling the ring out, like, pulling that ring away from that rod. So what does it mean? It means that your friction was also acting in the horizontal direction, right? So you have this obviously 10 Newton, I mean 10 sine G. And other than that, there was some reaction force also. But 1 minute, we have this one as given. No, we can calculate this, right? So there was some friction also acting in this case. If you want to find out that friction, we can write that, okay, R is actually equals to your 10 sine theta. There's no doubt in that. If R is 10 sine theta, so it becomes R 12 by 13 T. If the value for R is this much, I already know from the previous part what is the value for friction, 1.8, right? So, I mean, now I can use that R, I mean, friction is equals to mu R. Mu is 1.8, sorry, this is 1.89, this is 1 by 4, 12 by 13 T. So using this, you'll get one value for your T, which is going to be the minimum value, by the way, okay? So if we start, up to this, you were resolving horizontally, and from this part, I'm resolving vertically again. Okay, now then again, for this simplification, we have like what, 12, 4 into 13, that's going to be 3 by 13, so 1.89, 3 by 13 T, so the value for your T turns out to be 13 over 3. That's actually 8.19 again, but this also doesn't, 1 minute, am I making any mistake? It was mu value was 1 by 4, right? Yeah. Mu R was 12 by 13. 3 by 13 equals to that. So 1.89 into 13 divided by 3. This one also gives you some values like, 8.19 Newton. This is still not the smallest value that you are supposed to get. So if you think about this, that, your reaction forces, right, for minimum and maximum values, the minimum and maximum value for your T, right? If you think that the value of your T is very small means what? That it is not able to hold that ring, and the ring will slide down the road. If the ring is about to slide down the road, then your friction is about to be in this direction, okay? And if you are saying that, okay, the T is maximum, maximum means the T is now providing more force onto the ring, so now the ring will move in the upward direction, okay? So you can think about in this way. Let's not think of all these things in horizontal plane. Is just getting more messed up, but I'm not eventually getting the same answer. But we can think of this horizontal and vertical separately. So I'm saying that your tension was very small. It is not able to hold that ring attached to that rod. So the ring will eventually slide down the rod. If it is about to slide down the rod, then obviously you have friction here. Sorry, if it's about to slide down the rod, then you have T cos theta, reaction force and friction, everyone in the vertical plane, and in the downward direction you have your mg, right, which was just 0.2 g. Using this basic, I can understand that, okay, T cos theta plus reaction force plus friction eventually gives you mg. So now the reaction force I have to calculate, right? Oh, wait, 1 minute. Reaction force is, reaction force. I have to calculate the reaction force separately using that horizontal plane. That is going to be same for everyone, right? So resolving horizontally means that we are using resultant force 0, which was your RF, sorry, reaction force. This there also we have a reaction force, right? T sine theta reaction force, and then again T sine theta. So we have to basically focus on the horizontal plane to get the value for your reaction force, which is just 12 by 13 T. That means your new friction here in these situations is going to be 1 by 4, 12 by 13 T. That's just 3 over 13 T. So if this is the value for your friction T over 13 T, then I can use this idea. Now we have everything. I just have to make the value for T the subject. It's just going to be, okay, wait 1 minute. Cos 13 is also how much? It was 5 over 13. So we get 5 over 13 T. Any question from anyone?
So why did you add R dissolving vertically?
In the vertical plane.
Yeah.
Yeah, we won't in that case have R, right? Because we are only having that to the plane. Your rod was in the vertical plane. So your reaction force is only going to be in the horizontal plane.
Right.
So you have this T cos theta again for the maximum T max. T max means that your ring is about to move up the plane. So your friction is now in the downward direction with your weight. Right. So friction is now something that is changing its direction, and depending on that, the value of your T is getting changed. So we will update this again. We have T cos theta plus friction equals to weight. Everything was in equilibrium, right? This is your limiting equilibrium idea that for a very small value for t, obviously it was about to move down the plane, or it was for a very large value for t, it was about to move up the rod, right? These are your ideas about limiting equilibrium. So if I want to make t the subject, it's just going to be mg, which is 0.2, 9.8 minus your, wait, sorry, before that I just have to simplify. This is going to be 5 by 13t plus 3 by 13t, 0.29.8. This is going to be 5 plus 13 is 8 by 13. The value for t is going to be 0.29.8 multiplied with 13 over 8, right? This entire fraction gets divided. 0.29.813 divided by 8, that giving you 3.185, so approximately 3.19 Newton we can write. This is the minimum value. And for the maximum value, we consider friction was in the downward direction. So you have your T cos theta equals to mg minus T, so plus friction. That means if you take the friction on the left hand side, you have this 5 over 13t minus 3 over 13t equals to your 0.29.8, and this one now gives you 2 by 13t, 0.29.8, and eventually the value of your t is just going to be 0.29.813 divided by 2, which is just 12.74. Or we can write 12.7 Newton, right? So this was your T max. Is this clear for part 5C2? This was C1 and this was C2. Asri, any question from your side?
No, teacher.
Okay, then just 1 minute.
Call is now being recorded.
Tamit, did you saw the recordings for the vectors classes, by the way?
Yeah, man, I saw half of it, not fully.
Acha. Since you saw half of it, you'll be able to understand a few questions, I mean, a few concepts at least. I'll still try to
Yeah,
explain it as much detail. Acha, so
yeah,
we
sure.
only have last two questions. We'll start with question 6. This one says in this question, IJ are horizontal and vectors in east and north. At 12 p.m., yeah, at 12 p.m., a ship P sails from a harbor with position vector this much. That means it was not at the origin, right? And 30 minutes later, P, same shape, is at the position vector this much. P moves with a constant velocity, so you have to find out that velocity. This is how we are going to first understand it. Originally, always every position vector is measured with respect to the origin, right? So this is the origin. At the first, the position vector was 15, 36. 15 in the x-axis, 36 in the y-axis. So maybe this is where the entire boat started its journey from. So I'm going to connect the origin with that position vector. That first position vector was this much distant away from the origin. Then again, your after 30 minutes, it was 20, 34. If this is 15, then 20 will be somewhere after 15, and then 34 will be somewhere after 36. So this is how we can write it. But randomly again plotting these places, by the way. It doesn't have to be entirely accurate. These are entirely random. So 1 minute. I'm considering this is like 20, this is 34, this is 15, this is 36, right? This is how I'm actually drawing them. So we have, again, not necessary to draw all these things. We have the position vector from origin to the first position vector was 15i plus 36j, and then again your second position vector is 20i plus 34j. Then after this we have this one is your constant velocity, right? In real life, how the ship actually traveled is only the ship traveled actually this distance, right? But we always find out their position with respect to the origin. So this initial one with 1536 away from the origin, after traveling with a velocity of v with 30 minutes, 30 minutes is, by the way, how much? 30 into 60, right? You get the value. So 30 minutes will give you the velocity. 30 minutes with the velocity v will take you here, the second position vector, which is again 2034 away from the origin. If you go back to the question, your velocity is in kilometer per hour, so these 30 minutes have to be converted into hour, right? Which is going to be now 0.5. And again, I can understand from the arrows, right, that these two arrows, right, initial position vector and vt are in the same direction, and this is in the opposite direction. We usually consider this as, and since I'm working with what this is actually ship P I'm talking about, right? So if I'm talking about ship P, then let's think of this as R naught. Sorry, this is R naught. Initial velocity, initial position vector is always referred to as R naught, and this is your VT, and this is your RP, right? Position vector after 30 minutes is your RP of ship P. Then if I want to write an expression, it's going to be Rp equals to R naught plus Vt. You have to understand velocity to time also give you the same idea, right? Distance. Velocity into time is distance. So we can also write this as 0.5v. So let's just, for the time being, we can write it in this expression. This two adds up to give you the Rp. So if I want to find out V, I just have to make V the subject. That will be Rp minus R naught over T. So how much is your RP? RP is 20I plus 34J, and then again subtract this with R naught, which is 1536. 36J, dividing everything with zero point 0.5, and 20 minus 15 leaves you with 5I. 34 minus, yeah, minus 36 is actually going to be minus 2j, right? And dividing this with 0.5, 0.5 means what? Half. 5 divided by half makes it 10. 2 divided by half makes it 4. So we have 10I minus 4j kilometer per hour, right? This is the final velocity expression. Any problem from this one?
No, ma'am.
Fayad, Azri, Arif, any question?
No, miss.
Azri, I think you joined a little late. Did you understand this maths? Azri, can you listen to me? I think he is not in class, most probably. Then we'll move forward. For part A, we're done. After this, again, they're saying that at time t hours after 12 p.m., t hours means it could be any hour after 12 p.m. Just one minute. So as I was explaining that over here now they are saying in the previous case, they have clearly stated that what will be the final position and how you're traveling to the final position, how much time it takes, all those information was given. For the part B, it just says that obviously we're starting from the initial position vector, and okay, by 30 minutes you would have traveled to that 20i 34j, right? But maybe after t hours you have traveled a longer distance. I'm considering that t is obviously greater than 30, but it's not sure. T could be less than 30, greater than 30, but it's just that that t is not equals to 30 minutes. That means the second position vector now, which is considered as p kilometer, it should be somewhere other in any other case. So I just created, this is your second position vector after t hours, and you just have to find out this position vector t. So if I want to find out this displacement, what I have to add r naught with vt to get the value for p. Again, I'm not going to be able to calculate value for p because we have the time missing here. So I can write p is equals to R naught plus Vt, but I can understand these two are added together because they're traveling in the same direction, right? So R naught here is 15I plus 36J, and Vt is 10T minus 4T, right? So you can write 10Ti minus 4Tj. Even if you remove the brackets, take all the i's together and j's together. So you have 15 plus 10ti and 36 minus 4tj. This is the expression for your p kilometers. Any problem for this so far? You guys can listen to me, right? Any questions from this part B?
No, miss.
No, ma'am.
Okay, then B is done. Now again, if you're moving on to second part, right, this time we're talking about a second ship, which is ship Q, and that is also traveling with a constant velocity. T hours after 12 p.m. Position vector of Q is given by small q, where this is the expression, right? Like unlike in part A and B, where I have to find out that expression, like, what will be the final position vector of ship P after T hours. For ship Q, I don't need to do anything. The equation is already given. In this case, they're saying that P and Q are modeled as particle, and both ship maintain their course. Their course means they continue to travel in their specific direction. Verify that they would collide at 13:30. 13:30 means that after 1.5 hour from the release point, they will collide with each other. If they're colliding, that means what? They traveled, like, they started their journey with different approach. No problem with that. But this is, I think, for ship Q, so P, and this is for ship Q. So they are traveling different journey, but eventually the final displacement is going to be same, right? So this is the idea over here. If your ship P started with R naught VP and travels like this P, and your ship Q travels with R naught VT, travel and eventually ends up over here. That means what? Eventually, even if they started with a different journey at 13:30, 1.5 hour from their release point, they are at the same position vector. Collision means that they are actually at the same location, right? So if they are supposed to be, I mean, by calculation also, if I can prove that yes, after 13:30 or after 1.5 hours from the point of release, both of the ships are at the same location, that means yes, or both of the ships position vector is same, then yes, they obviously collided at that 13:30 p.m. Right? We just have to prove this in this section. So time is now given. I have the expression for your RP, which we calculated in the previous part B. So for C1, I am focused on ship P first, right? 13:30 means time is now 1.5 hour. So if I want to find out the expression for P, this is a mistake. It's supposed to be small p, right? Okay, then I have 15 plus 10, 1.5 I, then again 36 minus 4, 1.5 J, right? So I can just directly calculate it. 15 plus 10, 1.5, that's actually 30. And 36 minus 4, 1.5, which is 30 again. So 30i, 30j is the position vector of ship P after 1.5 hour from 12. And if I want to find out the same type of expression for ship Q now, 1 minute. Ship Q has a position vector formula as 42 minus 8. Time was the same for both the ships, so I just have to use this expression. $5 and now include the data. We have 42 minus 8, 42 8 1.5, 42 8 1.5, that is again 30, and 9 plus 14 1.5, which is again 30, right? So this is it. Now I have proved that after 1.5 hour, both of them are at the same position vector. So obviously they will collide. So when you don't need to write a statement, you can just write that after 30 minutes, sorry, after 1.5 hour, or I should better write it as like at 13:30, the P is equals to Q, so they collides. Right, this is only, writing this much is only enough. And this is everything you need to do for your part C1. Any problem from this statement?
No, miss.
So then this is it for your C1. Let's move on to your next part. Then again, they are asking that find the position vector of the point at which the collision would occur. We already calculated that, right? It was 30i plus 30j. When using that, I proved, but then again, they're asking to find it separately. So I'll just write this down, that position vector. No calculations are needed over here, okay? I did all the calculations previously. So it's just 30i and 30g. That's it. I'm not going to write anything else after this. It's just this much kilometer. That's it. Then again, let's see still how many marks were there. Yeah, 4 marks. This is 3 mark and this is 1 mark. Okay. Then again, after this, it says that at 12:30, now Q changes speed and direction to avoid the collision, right? They have calculated this previously before the start. So now they know that, okay, by 12:30, if they continued at that speed and that direction, they were supposed to collide with each other. So in order to avoid collision, Q will take some changes. It will change the velocity and direction also. So it says that shape Q now travels due north with a constant speed of 15 and P remains the same constant velocity throughout. Find the exact distance P and Q at 12:30. Sorry, 14 to 30. 14:30 means 2.5 1 minute. Yeah, 2.5 hours from the point of release, right? From this statement, I can find out the equation for your velocity of ship Q. Ship Q now travels from the origin and in which direction? 15 kilometer due north, right? North have the vector J. So if north has a vector J, I can easily calculate the velocity for your ship Q. Yeah, ship Q. It's going to be 15J only, right? Nothing changed over here. It's just going to be position vector of Q is just going to be 15J. Right? V is 15J. Or we can also add 0i plus 15J because obviously on the y-axis, you don't have any value for I, right? So if you still want to write it in format of ij notation, you can write this as 0i 15J per kilometer per hour. This is for, by the way, VQ now, right? New velocity for VQ. Whereas P continued to the same pathway and same velocity, but Q would change its directions. Other than that, do we know anything else? In 1 minute. No, one. I cannot see any changes here, right? Exact distance between P and Q at 12:30, 14:30. 10:36, 4. Oh, this is not starting from exactly 12, right? This is how it started actually. Q for the initial 30 minutes would travel in that same expression, that 42 minus 18 and 9 minus 9 plus 14j. But now after 12:30, Q will change its position. So you have to find out that within that 30 minutes, Q would have obviously traveled some distance, right? So first, we have to say that for part D, we're focusing on sheet Q, distance traveled from the 12:00 to 12:30, right? So we have time as 1.5 hour, and the expression here for Q was actually 42 minus 8, 1.5 I plus 9 plus 14, 1.5 J. So now you just have to calculate them. 42 minus 8, 1.5, that becomes 42 minus 8. Oh, sorry, I made a mistake. This is 0.5, right? When from 12:30, so this is 0.5, sorry. 0.5, 0.5. You get 38 I, and then again 9 plus 14, 0.5, that's actually 16 J. Right. So what happens is that when ship Q decides to change its velocity, this is the initial position vector for ship Q then. Okay. So this is how ship Q was actually traveling. If I want to draw ship Q separately, originally ship Q was at a position vector maybe at this point, right? Then for 30 minutes it started like continued to travel in this case, and after that it continued to move with the velocity of this, right? So this is how the entire thing was changing. This is the initial R naught. This is the displacement traveled within the 30 minutes, T30. Okay, and this is your final velocity with which it was moving. Right, this is the final velocity, which is VP 0I plus 15J. As it was only traveling with 15 kilometers per hour in the north direction, right? So it does only have the J unit and not any I unit there. So again, if I can understand, this is again irrelevant for me, right? Whatever it traveled, that is irrelevant. Now this is going to be the initial position vector. Like for this section, right, which I'm considering that from 12:30 to forward, that is the initial section, initial displacement that I want to calculate. That from 12:30 to 14:30, that is on rest of the 2 hour, how far Q traveled in those rest of the 2 hours. I'll have to calculate that also. This is the displacement that the Q traveled in the first 30 minutes, and then again from 12:30 to 14:30. 12:30 to 14:30. What is the displacement? Tamid, any question from your side? I think there was some problem. So from 12:30 to 14:30, I have to now find out the new position vector, right? So I know that, okay, within this time, we are traveling in this way. Initially, you are at this value. What is the value? This is a 38 plus 16 that you calculated, that you traveled within the first 30 minutes. Right, this is your R naught net. Then after this, you have traveled entirely vertically upward with that 15I vector. 15J time is your 2.5, right? Velocity into time will leave you to the final position vector. This is your now RQ, right? This is your final position vector. And okay, understand this is RQ. If I want to find out the value for RQ, it's just going to be R naught. This is your R naught now. R naught plus VT. R naught is 38I, 3016J, and then again how much? 2.5 into 15, right? 2.5, 15J. So we basically get 2.5, 15 is actually 37.5. 38 will remain like this. 16 will be added with this. So 37.5 plus 16 leaves you with 53.5G, right? So 53.5G. So we have RQ, that's correct. Then again, after this, this is the final position vector. Okay, at 12:30, sorry, at 14:30, this is the position where ship Q will be present. Then again, you have to calculate that at 14:30, where ship P will be. So if I want to then again work for ship P, Ship P, by the way, didn't change its position, didn't change its direction or speed. So obviously the expression that you calculated over here for ship P 15, 10, 36, 4, it will remain like this. I just have to insert 2.5 into the values for P. 15, 10, 36 minus 4. So RP is just going to be 15, 10, minus 4, 10, 10, 10, okay. 15, 10, 2.5, that is actually 40 I, and 36 minus 4, 2.5, which is again 26J. If I want to find out the difference in their position, if you go back to the question, they were asking you find the exact distance between P and Q 1430, right? Again, they're talking about distance, not displacement. So this is how I'll last draw a diagram over here. Ship Q traveled in this pattern, right? First it was at this value, then it started with like traveled with certain velocity for the first 30 minutes. Then again it traveled in the vertical plane, and this is where the final position is there, right? So this is how ship Q traveled. This is your like over here. If I just 1 minute, I want to create it as a big diagram since we have space. So these are just for understanding. So no need to obviously draw them on your copy. And this one, right, initially it was at some value which I don't know. This is your R naught, right? Then this value was your velocity. T was 0.5, right? Because of them, it reached to this position vector 1. Okay, and this position vector 1 was how much? This position vector 1, that was given using that expression there, right? Which was, I think, 42 minus 8t, then 9 plus 14t. That was the expression for this position vector, which you calculated as 38i plus 16j, right? Using that 0.5 hour, you get this as 38i plus 16j. After this, what happened? They again started traveling with the 15j position vector with 2.5 hour to eventually reach this RP, right? So this RP is actually what you got for the final part, which was 3853. So 38 plus 0.5j. And again, this is the diagram for your ship P, right? Where did ship Q started from? It was 15, 20, 36, if you remember. This is maybe the initial case for your ship P. And after traveling at that same velocity, 10j minus 4, 10I minus 4j for 2.5 hours, it eventually reached to maybe this case. So I have to write all these informations now. This one was your R naught that was given us. You don't need to write all these things, to be honest, right? We already have calculated everything. 1536, and then again after this was the velocity, which was your 10I minus 4j for 2.5 hours, right? Adding them gave you the final RP. Yes, sorry, made a mistake. This is Q. RQ, and this is for RP. Now we are calculating. RP is what we calculated in the previous part, lastly, 40 and 26J. So we have this one as RP, which is 40I 26J, right? If that's the case, then you actually have to just find out this value. Over here, all the informations are there, right? They just give you that what will be the final position vector of P and Q, and you just want to find out the difference between them when the time is 2.5 hours. So you just have to find out the black line over here. Is this clear what I'm trying to find out? This is your RPQ. I want to calculate that. To be honest, you can calculate this in QP also. That is not a problem. They never ask you to find out the displacement. They ask you to calculate the distance. So distance can be in any format, right? PQ or RQ, no problem. I mean PQ or QP, that's not your concern. So from this part, I just have to work with this portion of the graph. Just copy this and paste it. Right, so I'm only going to work with this portion of the graph. Right, this portion of the graph is important for me. All the other informations are already calculated. I want to find out this line, right? What is the value for this line? So that's why we're only focused on this highlighted graph over here. Any problems so far?
No, miss.
Tamid, Arif, Azri, any question from you guys?
No, teacher.
So I guess for Tamid and Arif also, you guys don't have any problem. So I want to find RPQ, right? I can understand adding them will give me RQ. So I can write, okay, RPQ is equals to RQ. I should use small q. Then I will just write RPQ. It will be RQ minus RP. So RQ is how much? RQ is actually 38 plus 53.5 G, and then subtract RP. RP was 40I plus 26G. So you basically have like 38 minus 40, which is minus 2I. 53.5 minus 26, 53.5 minus 26 is 27.5. Wait 1 minute. 26. Oh, wait 1 minute. Over here, you have to understand for this one, right? I mean, we're starting from 12:30 to 2:30, so which is actually 2 hours here, not 2.5 hours, because 30 minutes was already passed in reaching this new position vector, right? This was supposed to be 2 hours here, not 2.5 hours. So it will be actually 15 2 plus 16, that's 46. Is this clear how we calculated this as 46 and not that 53.5? Is this well, the mistake I made over here? Is this clear?
Yes, miss.
Okay, then again, now I have to just change that. Everywhere I have used, this is supposed to be 46 G. So we have 46J, 1 minute, minus your 40I. So 38 minus 40 is what? Minus 2I. 46 minus 26 is going to be 20, right? Yeah. 46, 26 is, yeah, 20. Positive 20J. Now this is again what? This is your vector, right? Which is known as displacement. If I want to find out the distance is going to be RPQ modulus. It's just minus 2 square root. So basically have 4 plus 20 square. That's just 101. Okay. 2 square root 101. In decimals, if you want to write, you get like 20.1 distance between them. Okay, you can write it as 101. I think in the question, they asked you to keep your answer in exact value. 1 minute. Yeah, exact distance. Exact distance means I have to keep my answer in the simplest SARD format. So I should write it as 101 kilometer. And that is all the working you need to do for your part D. Right? Yeah, this is decontinuation. This was also decontinuation. Very big maths, right? They're only giving you no, only 15 is also a very large mark to get. They're giving you 15 marks for all these calculations. Any problem from this entire part?
No, miss.
Arif, is there any questions from your side? Right, we completed all the questions then. Let's move on to the last question here, which is about pulley. Right, I can see that it says figure 4 shows a mass A, so block A of mass M held at rest on a rough plane. Rough planes means friction is there, rest means all the forces are balanced. The plane is inclined at an angle alpha to the horizontal, and the coefficient of friction between the plane and the plane is mu. At one end of the inextensible, so at one end, a light inextensible string is attached to A. The string passes over a smooth pulley, which is fixed at the top plane. The other end of the string is attached to block B, whose mass is Km, and block B hangs freely below pulley with the string taut. And the spring from A, so the string from A to the pulley lies along the line of greatest slope of the plane. That means the string is inclined parallel to the plane, and A and B are both modeled as particles. When the system is released from rest, A moves up the plane, and the tension in the string is this much. Given mu is this, tan alpha is this. Calculate the magnitude of the acceleration, giving your answer in the given G. So first thing is that tan alpha is given as 7 by 24. So if tan alpha is given by 7 over 24, I will always draw the diagram for this triangle. If this is alpha, this is 7, this is 24. Hypotenuse is just going to be, you have to calculate it, right? This is the hypotenuse. If you calculate the hypotenuse, that's actually 24 square root. 24 square 7 square, that's 25, right? So if this is 25, I can easily calculate, get my values for sine alpha, opposite hypotenuse, 24, 25, right? I have anyway have to use this thing, so just keeping this over here. Again, if I want to draw a very clear inclined diagram, like how the forces are acting on the different particles on the plane, then this is where one particle was, this is where the pulley was, and this is where the other particle was hanging from, B. Okay, this is how it looks. Now, this is the vertical plane, then horizontal plane, this is the point where weight is acting vertically downward. This is the weight of particle B. And your tension is obviously above particle B, right? This is for B and this is for A. Weight of A was mg, right? If this is also alpha, this is going to be mg cos alpha. This is going to be your mg sine alpha. And I know that particle A was about to move up the plane or was moving up the plane when we released the system from rest. So we also have a mu r friction. This is your reaction force. And on the forward force, you just have tension there, right? And for particle B, we have kmg, and this is your tension here. So these are all the forces that I know is present or acting on the particle. So if these are all the forces, then what are the values? T has a value for, 1 minute, 4 by 3 mg. So we get 4 by 3 mg, Then your what? Mg sine alpha has a value of 7 over 25, cos alpha has a value of 25, 24 over 24 over 25. So I have to find out the first vertical component. Okay, so if I focus on resolving vertically, then what do we have? Resolving vertically, we have all the forces are balanced, so resultant force is 0. So we have R minus mg cos alpha 0. Cos alpha was, by the way, 24 by 25, which we calculated previously. So R eventually turns out to be 24 by 25 mg. Right, this is the value for R. Now, other than the resolving vertical forces, now if we start resolving horizontally, before we start with the resolving horizontally case, I have to work with the friction forces, right? Frictional forces was, by the way, it's always mu times R. The value for mu over here was, I think, 1 by 4 or 1 by 3. Mu is 1 by 3. So if mu is 1 by 3, then I have to write friction as 1 by 3. R is how much? 24 by 25 mg, right? So you get 24 by 25 into 1 by 3, which is going to be 8 by 25 mg, right? This is your friction. I know that it was about to move up the plane, so there was obviously an acceleration up the plane, so which means also tension is greater than all the downward forces, right? As it was moving up the plane. So in that sense, we can continue from this one, is that your resultant force is equals to ma. Now it's not 0, and it's going to be how much? Tension minus mg sine alpha minus friction is equals to your ma. Mass of particle A was also A. Again, all this time I was focusing on particle A only, right? Not onto particle B. So I can write tension was what? 3 by 4, I think. I have written that. 4 by 3. Okay, so we have 4 by 3 mg. Sine alpha is, by the way, 7 by 25. So 7 by 25 mg. Friction is your 8 by 25 mg equals to ma, right? Everyone have m, so you can just write 4 by 3. I mean, just add all the values, right? So you have 4 by 3 minus 7 by 25 minus 8 by 25. You get 11 by 15. From this, I get 11 by 15. 11 by 15 mg I can cancel the masses. You eventually end up getting 11 by 15 g. Right, now if you go back to your question, let's see if they give you some values. No, they are only asking for the acceleration in terms of g, so we calculated that. Any problem from this calculation?
No, teacher.
No, miss.
So then that's it. Right, we calculate the value for acceleration. Just have to write down the unit, meter per second square, right? So then this is for part A. After this, part A1. Now they're saying that calculate the value for k. I know that they were connected particles, right? K was the mass of, like, part of the mass of particle B. If they are connected particles, they both have to accelerate at the same idea then, at the same value. So all this time I was focused on particle E. I don't want to move to a new page because we can easily get access to the diagram here. Right, all this time I was moving, I was calculating with your particle A only. Now we'll focus on particle B. For particle B, If I draw the diagram, tension is kmg. Obviously, a particle B was moving in the downward direction, so weight is now greater than tension for particle B. So if I write Rf equals to ma, it's going to be kma, right? So for Rf, we have kmg minus tension kma, include the fractions. T is your 4 by 3 mg. Then this one is going to be, A was 11 by 15 g, right? So we have 11 over 15 kmg again. So what I can see is that we have kmgs. Let's take all the kmgs together. So we get kmg minus 11 by 15 kmg equals to 4 by 3 mg. So if I can take k as a common factor, not exactly k as a common factor, I can just subtract them. 1 minus 11 by 15 mg, yeah. We get 4 over 15 kmg and then 4 by 3 mg. So obviously, so kmg, so not mg. So this mg and this part of the mg will cancel each other out. The value for your k is only going to be 4 by 3, dividing this with 4 by 15. So you get 4 by 15, which is 5 only. So the value for your k is 5. That means particle B is 5 times as heavy as particle A. This is all the things you need to do for your particle B calculation. Any problem from this part?
No, teacher.
Okay, then right, this was a common diagram for part A calculation. After this, if I want to move on to your part B, now they're saying find out the magnitude of the resultant force exerted on the pulley by the string, giving an answer in terms of M and G. I can understand that these tensions I was drawing with respect to the particle A and B. Right, if I want to draw their tension with respect to the pulley, then tensions will actually act in the opposite direction. Sorry, I have to copy. I don't need to talk about all these things over here, not important for me. Right, over here for the pulley, the tension is acting, one in acting in this case, one acting in this case. If you understand, this is alpha, this is 90 degree. The angle between the two tensions over here is going to be 90 minus alpha, right? 180 minus 90 minus alpha is actually 90 minus alpha. So if that's the case, I understand. And again, what this means that if I draw a parallelogram, okay, that will be easier for you guys to identify the final direction. This is T1 and T2. Copy. This is just their rearrangement of the vector diagrams so that I can finally identify that what will be the final direction. So this is your T, tension from particle A, tension from particle B, repetition of tension from particle B, tension from particle A. This is where your pulley was. So I can easily identify this is where all the arrows are heading towards. So this is your angle. This is your final vector, right? So this is your final vector. If this angle entirely was what? 90 minus alpha, right? 1 minute. Just think of this one. This angle is the same angle that we're creating over here, right? If inside angle is 90 minus alpha, rest of the angle is going to be what? 180 minus 90 minus alpha is going to be just alpha here, right? You have to think about it in this way, that if this is how We are breaking the angle. This is your 90 minus alpha. Then this one is going to be sum of a straight line minus 90 and minus 90 minus alpha, right? So 90 minus 180 minus 90 is another 90. Wait, am I making a mistake? No, 180, 90 minus alpha is 90 minus. So this one also becomes 90 minus 90 plus alpha, right? This one now becomes 90 plus alpha over here. Is this clear how we have calculated the outside angle?
Can you explain it again?
Do we understand how am I getting this one? This is sum of
Yeah.
a straight triangle, right? 180 minus 90 minus alpha. So we are getting 180 minus 90 minus alpha. That is actually 90 minus alpha. So again, if this is a straight line, this is also another 180. So another 180, you have to subtract 90 minus alpha to get this angle, right? This theta over here. So that theta is going to be 180 minus the first part. I mean, over here, only the sum of a straight line is divided into two angles, right? One is theta, one is 90 minus alpha. So we have 180 minus 90 minus alpha, which is 90 plus alpha. Is this clear?
Yes, teacher.
So which means this angle is going to be 90 plus alpha. So if you just focus on this triangle, right, we can easily calculate your final answer. We are only focusing on this part. Over here in this part, I want to find out this final tension vector, right? Like tension resultant over here I want to calculate. So I can think of this as a cosine rule, right? And in that cosine rule, I have to wait, yeah, we can think of this as a cosine rule formula. Problem is that alpha I have to calculate now. Like what was the actual value for alpha, you have to find out now to move forward with this type of calculation. If remember, tan alpha was 7 over 24, right? So if tan alpha is equals to 7 over 24, then alpha itself becomes tan inverse 7 over 24. So which is tan inverse 7 over 24. So that is like 16.26 degree. So your 90 plus alpha turns out to be this much plus 90. That's like 106.26 degree. Right, so if this is 106.26 degree, I can easily use cosine rule to find out this dr. So cosine rule is going to be, these individual tensions we have calculated, right? How much was that? That was actually 4 by 3. Yeah, it was actually 4 by 3 mg, right? Yeah, 4 by 3 mg. Wait, can we calculate this? Because m was not given. Yeah, in terms of m and g, you have to just find an expression actually. You cannot calculate that directly. So we can write it as how much? T square plus t square minus 2t cos 106.26 degree, everything under the square root, right? Again, I have to break down this t square. T square itself was how much? 4 by 3 whole square, right? Which is 16 by, over here t square is actually 4 by 3 mg whole square, which is, by the way, 16 by 9 m squared g square. Adding this with another t square is 16 by 9 plus 16 by 9, which is 32 by 9. So you have 32 by 9 m square g square, and then again this is how much? 2t cos this much. 2t is going to be 8 by 3, so minus 8 by 3 mg cos 106.26, everything under the square root, right? So this is an expression that you can get in terms of mg, and you can m squared g square actually. Wait, so this is also going to be 2t square, right? Because this is 2ab. Sorry, made a mistake. So this was also going to be 16 by 9 into 2, which is 16 by 9 into 2, right? So it is going to be 32 by, it's 16 by 9. Yeah, we can write this is also 9 mg square, m square g square, 32 by 9 m square g square, and this angle value, right? This angle value is, by the way, how much? 106. This is your tan 90 plus alpha it was. Can we break this down anyway? Tan 90 is sine by cos. Yeah, we have to break this down also actually because they're asking for expression. So you have to break that down. If I'm working with, I mean, not exactly anything, we're working with cos 90 plus alpha, right? Are we supposed to use, yeah, we have to use in this thing. We're working with cos 90 plus alpha. We have to use the addition formula for trigonometry, which is cos 90 cos alpha minus sine 90 sine alpha. Right, cos 90 is actually 0, I think. Cos 90 is 0, so multiplying this with cos alpha is going to be 0. And this one is going to be sine 90, that is 1. And sine alpha was how much? Sine alpha was 24 by 21, right? So you get 24 by 25. So this is going to be 24 by 25. Not using the minus word because that's not quite relevant here. So again, if we start with your expression now, your TR was 32 by 9 m squared g squared minus 32 by 9 m squared g squared, multiplying this with that 24 by 25, everything under square root. You can simplify them, right? 32 by 9 into 24 by 25. You get 256 minus 75, then 1 minute. 32 by 9, 256.75. Mm, 1 minute. Cos alpha plus 90 we have, so that we'll be working with, yeah, cos 90 cos alpha, then minus sine 90 sine alpha. Sine alpha was, oh, it was 7, sorry. Then 7 by 24, right? So then you get 32, 9 minus 32 by 9 into 7 by 25. I don't think you have to simplify all this way, just 1 minute. Now we are doing this t square plus t square minus 2 dt, that's t square plus cos angle. Cos angle is 90 plus alpha. 1 minute, we just check the formula. Cos addition formula. Yeah, cos a plus b is cos a cos b minus sine b. That's correct. That's what we are using also. We have cos 90 cos alpha, then sine 90 sine alpha. Cos 90 is itself 0, multiplying with cos alpha is nothing. And sine 90, okay, we have to use the minus sign here. That will create some change, right? So we have 32 by 9 plus it will become 32 by 9 with 7 by 25. Yes. Then if you simplify this, then you're supposed to get, like if you add all this thing, like 32 by 7, 7 by 25, you actually get 225, 4 by 25. So 32 by 9 m squared g squared plus 224, 225 m squared g squared, everything under the square root. And now eventually adding these two numbers is 1024 225 square root mg. Right, outside the square root, this is going to be mg. So this is how you have to simplify. Quite very difficult, I would say, because it was quite unique to use that addition formula for cos. Right, otherwise the format was same. Right, so far the format was entirely same, but we had to use a cos formula here and then insert it in the equation. That made the entire maths difficult to work with. Is this clear? Any problems so far for part what value? This is C, I think, right? B. Is this clear? Fayad, Arif, and
Yes, miss.
Fayad, Arif, Azri, any questions?
No
No
question.
miss.
Oh, okay. Then